So let's try a few more of these. Okay, so what you'll see about this particular equation is you have bases 4 and 8. Well, 4 and 8 can be written as a common base. So let's first try 4. If you wrote 4 to the 1, you would get 4. So that would work on the right side. But if you wrote 4 to the 2, you would get 16. Well, that doesn't give you an 8, so that means 4 is not the proper base. So instead of 4, let's try a little smaller. Let's try 2. Well, 2 to the 2 is 4, and 2 to the 3 is 8. So I have a 4 and an 8 there. That means I can write this particular equation with like bases. 4 can be written as 2 to the 2nd, and 8 can be written as 2 to the 3rd. Now let's put our exponents back in there for the equation. So 8 to the x plus 2 equals 4 to the x minus 3. So that's how we're going to set that one up. Now remember your exponent rules. They say when you raise a power to a power, you multiply. So writing this in a more usable form, I'm raising this power here, 2 to the 3rd, and I have an x plus 2 here. And I also multiply these exponents. So that's 2 to the 3x plus 6 equals 2 to the 2x minus 6. So now I have like bases. My exponents are in a simplified form, and that's how it would look so far. Again, when you go back to this red step, the way that I went from the second line to the third, when you raise a power to a power, you multiply. So I'm multiplying 3 times the expression x plus 2, and on this other side I multiply the exponent 2 times the expression x minus 3. Now once you get here, remember all you have to do is set the exponents equal. So my students always ask me, you can just drop the 2's? Yes, you can. Here's why. You have an equation there, and I know that 2 equals 2, so the bottom parts are equal. So if the bottom parts are equal, that means the top parts have to also be equal. So you can drop the 2 bases just to solve the exponential equation. To solve this out, I'm going to move the 2x over. I'm going to subtract 6 from both sides. And x would equal negative 12. Okay, and that's your answer. Okay, let's try another one. When I get ready to work this one, I notice that 4 and 13, they don't have anything in common. So this is not a like base type. This is one where you have to use a calculator. Okay, so what you have to remember to do is you're going to take the natural log of both sides. So I'm going to take the natural log of the left, and I'm going to take the natural log of the right. Once you take the natural log of both sides, what you can do after that is use your exponent rules, and that main one there is the power rule. We can bring this power out in front. So 5x minus 8 comes out of the exponent position and goes down on the regular playing field. So now you just have one equation that's straight across. Now we have to solve this equation for x. We want x on a side by itself, and the easiest way to work it in the calculator is to get rid of the natural log first. Right now the natural log of 4 is being times by the red expression. So to get rid of that, or to undo the times, I can divide both sides by the natural log of 4. So 5x minus 8 would equal some number. Now let's go to our calculator and see what that number would be. If you took the natural log of 13, you get 2.5649. If you took the natural log of 4, you get 1.3863. And of course, rounding that far out is not a big deal here. So if you'll take the natural log of 13 and divide it by the natural log of 4, what you should get at this point is 1.8502. Again, anything close to 1.85, you're going to be good. Okay. Now on the left side, you still have the 5x minus 8. I'm just a little slow in bringing it down. Okay, so that's what your equation would look like. So once we get there, what we can do is add 8 to both sides. So 5x would equal 9.8502. We can divide both sides by 5. And x would equal 1.9700. And that would be our answer. I think we have one more of these, so let's knock that one out. When you look at this one, you see an E equation and you immediately think, oh no, it's E, that's bad. But I want you to think of E as E for easy. So think of this one as an easy equation. Now, just like we've been working our other exponential equations, you have to see if you can write them in terms of the same base. Well, you can't write E in terms of any base, so that means you're going to have to use the natural log steps. So it's exactly the same steps that we used before. You're going to take the natural log of both sides. So I take the natural log of e to the 5x minus 4, and I take the natural log of 23. Your next step is to use log properties to simplify. Now, there's a log property. It's been a little while since you've seen it, but remember that natural logs and e's are inverse operations. So if you have a natural log and an e together, they cancel one another out. So this is just going to leave you with 5x minus 4. A natural log and an e are inverse operations. It's kind of like multiplying and dividing by the same number. It cancels out. So when you have a natural log and an e together, they cancel out, and that leaves you with 5x minus 4. At this point, do not move the 4. It's very tempting to say, oh, I'm going to add 4 to both sides, but don't. Not yet. The first thing you need to do is find the natural log of 23, and then you can move the 4. So the natural log of 23 is 3.1355. Now, as soon as you get there, now you can move your 4, add your 4 to both sides. Once we get there, we can divide both sides by 5. And x would equal 1.4271. And that's what it would look like.